Back in section 10.2, and we had taken a look at some data and created a grouped frequency table. And let's actually start with that table and taking a look at where we were with that table, because that table information is what's going to be used to create the next graph. So when we were looking at creating a grouped frequency table, we were told to use the letter grades that correspond to our traditional grading scheme, right, at these points. So that's how we came up with those values. We use the tally column just to be able to make sure that we have all of the values recorded in their appropriate row, and then we counted them up. All right, so a grouped frequency table actually allows us very easily, you wouldn't have to do it, but it allows us very easily to create a histogram. So a histogram is sometimes commonly called a bar chart, but it's slightly different. We'll talk about a bar chart in a minute. It actually looks like vertical bars, or sometimes they're drawn horizontally. We're going to draw one vertically, but they could be horizontal. The categories are shown along an axis, and then the frequency is along the other axis. So this is the same information that the last problem was. So the same data as the group frequency table. And we're going to create a histogram. So what we do when we create a histogram is we first create the x and the y axis, or the horizontal and the vertical axis. Typically, the way that the description is set up, we're going to put our values along the bottom and then our frequencies along the side. So the bottom values are actually going to represent these particular grade distributions. Okay? So either you can start with smallest and go to largest, or you can start with largest to go to smallest. Just because it's an XY axis, I'm going to start it with a 60 and go up from there. Now, there's a few things to be aware of as we start to create a graph. One thing to be aware of is that your spacing should look pretty even. Okay? Second thing to be aware of, and I didn't do it, so I'm going to go back and actually do it now so that you guys are being able to see this, is that if you don't start at 0, you need to show a break in the graph. So it does like this. It looks like there's sort of a jagged mark in the graph that shows, hey, I'm not starting at 0. Okay? It gives the viewer and it gives the researcher the opportunity to say, there's something different about this graph, and so it's sort of designating that. Now, our frequency along the side will depend on how the frequency was in our data set. We actually have one frequency that's the number 1 up to the number 11. Okay, so what I'm going to do over here is, and you can mark them out by 1s, that's okay. I'm going to mark mine out by 2s. So 2, 4, 6, 8, 10, 12. And again, they need to be evenly spaced. Otherwise, it gives the illusion that something's happening that's really not supposed to be happening there. You can label them. You don't have to label every single one of them, but you need to label a couple of them in there at least to give a reference that you're using them by 2s, in other words. This piece over here is the frequency. So you need to write frequency over here. And what are the values along the bottom? Those were the test scores, or the grades. So you can write grades if you want. I'll be real clear to write test scores. And none of this is actually the title for the graph. This is just labeling the axes, what in the world these axes represent here. So what is this graph going to be? What is my title for my graph going to be? What is it? Okay, what was it that we had before, Beth?
Grades from second exam.
Grades from a second exam. And then what we're going to do is we're going to create bars of the corresponding heights that actually match up with our data. I'm going to keep going back to this distribution here because I already counted them once. I don't want to count them again if I don't have to. So the first distribution, or the first values in our table here, our graph here, go from 60 to 70. And the values from, in fact, 60 to 69, but 60 to 69 have one value in that range, right? So you're going to draw a bar of height 1. And then the second one has 2 in it, so you're going to draw a bar of height 2 here. The third one actually had 4 in it, so you need a bar of height 4. And then the last one has 11 in it, so it needs to be a bar of height 11. something like that. And this gives a visual picture to the numeric picture of the last table. That's all it really does. It gives us an ability to just look at something and see very quickly the information instead of numerically thinking about the information. Everybody good with that? Okay, let me tell you about the difference then between this and a bar graph. A bar graph is very much like a histogram. It has bars in it, all right, just like it sounds like. But they have spaces between the bars. And while it sort of doesn't really fit in quite with this data, it kind of does. So if you take a look at this data right here, my x-axis down here at the bottom, or my horizontal axis, has numerical values on it, right? It has numbers. And it actually represents, or you can actually very clearly see the range of numbers. So while you know 60 to 70 is not, is a D, it doesn't say D, right? Okay. A bar graph, what it does is it groups the information by category. So instead of it saying 60 to 69, it's actually going to say D. Now, somehow that hides things a little bit, because what that does is it allows me, for instance, as a professor, to decide, you know what, that person who got a 58, man, they were really close, I'll count that as a D too. So there's something sort of hidden in the way that that's set up, yeah? I mean, we don't really know the scale when I do that all of a sudden. It's not quite as clear as the last one. But there's other things where there's just categories, right? Like if you were doing this and you were comparing male versus female, well, there aren't any numerical values to put with that, right? So you have a bar for males and a bar for females. That would make sense because there is a category clearly. I wanted to use the same information, so we're going to graph the table the same way. But instead, again, on the bottom axis, we're going to have the categories be letter grades. So again, go ahead and mark over here on the left-hand side that we're not indicating that there's a 0 here. That wasn't good. All right, something like that. So we're going to have a category down here that represents D's. We're going to have a category that represents C's, B's, and A's. And again, your bars need to be roughly the same width, okay? So if you start making something significantly larger, you've got an illusion of something going on that's really not going on. And then I'll mark these out by 2's again. 2, 4, 6, 8, 10, 12. Did you guys have a question? Yep. Because our bars are going to be separated by space.
Okay.
So like when I draw the first one, let me show you, Hannah. When I draw that first one right here, whoops.
Yeah, you just want a space.
I want a space between them. And so that second little line there is just going to represent the distance that it is from the next bar over. Yeah, good question. Let's go ahead and draw our bar heights in. Well, I'll put my numbers here first. So this is 2, 4, 6, 8, 10, and 12. So I've got bars the same heights as before. So a bar of height 1, a bar of height 2, a bar of height 4, and then a bar of height 11. I need to label everything just like I did before. These are grades or test scores or something like that. This over here is still frequency. And then these are the grades from a second exam. But make no mistake, this information in this chart has less information in it than the last one had. It does not tell you what a D is, does it? You might be thinking, hey, a D is 60 to 69, and you might be wrong. I had a class in graduate school where a 70 was an A. 70 to 100 was an A. 55 and up, 55 to a 74 was a B. But you know why it was like that, right? Because the class was really, really hard. But the information displayed wouldn't show that if I were talking about that particular class, right? You might look at the information if that teacher did a sort of a bar chart and assume that an A was 90 to 100, and you would be assuming incorrectly. So this definitely gives you less information when there is numerical data to back it up. But sometimes there's just not numerical data that makes any sense, like the male-female business, okay? All right, let's take a look at another one. A double bar graph. Okay. So we did something that was like this before. Do you remember we did something where we called it a back-to-back stem and leaf plot? You guys remember that one? This is a bar graph that does the same thing as the back-to-back stem and leaf plot does. It creates bars of the corresponding heights to how many people have whatever grades. Now we've already created a bar chart for the second exam. And then we're going to create a bar chart basically for the first exam. And as we're taking a look, we're going to use the back-to-back stem and leaf plot that we did in example 4 to create this bar graph. So try to, if you can, flip back and forth between example number 4, which had the back-to-back stem and leaf plot, and this example number 8 that we're on to create the bar chart. All right, so taking a look at this particular bar information, or information for this bar graph, we're going to do this in terms of A's and B's and C's and all the way down to F's. I'm going to actually flip the graph around because it is categorical data, so it really doesn't have numerical values innately associated with it. I'm going to put my A's first and my F's last. Is that okay? I mean, we could have done that even with the numerical values. It just sort of feels kind of weird to put a 90 before a 60 on an x-axis. So I'm going to do a back-to-back, or I'm going to do a double bar chart with the A's first. All right, so I need a break in my graph at the beginning. Sorry about that. I didn't do it again. Okay, so there's a break at the beginning because I'm not actually at a 0. There's no such thing as 0 in this particular one. So these are my A's. And I'm going to have 2 bars, and they're going to be right beside each other. Okay, the 2 bars for A's are going to be right beside each other. And then I'm going to have this little break. And then I'm going to have my B's. And a little bit of break. These are my C's, and I've got a little bit of a break. My D's, a little bit of a break. And then my F's. And the vertical axis is still frequency, so I'm still going to go by 2s.
So even if like the bottom isn't numbers, you still have to do the break in the
Yes, we're going to still do a break in the graph to represent that. I'm trying to decide if it would be actually considered completely incorrect if you didn't, and I'm not coming up with an example of when I've done one that's quite like this on like a homework. So you may not even encounter that perspective, but go ahead and put it in there to show the break in the graph, yeah. All right, so here's 2, 4, 6, 8, 10, 12. I have no idea why I made those a little bit bigger this time, but apparently I did. All right, first exam. Look at the first exam information. How many A's were on the first exam? Four A's, huh? Try to decide how I want to do this. Let's do it like this. So we have 4 A's on exam 1. How many, let's keep looking at the exam 1 information. How many B's were on exam 1? 6. How many C's were on exam 1? 4. How many D's were on exam 1? None. And how many F's? 4. Okay, so those green bars are representing exam 1 grades. So these are grades right here done. Well, we'll write test scores again, just like I did before. All right, let's look at exam 2 then. How many A's were on exam 2? It was 11, right? $11 A's in exam 2. How many B's?
4.
How many C's?
2.
How many D's?
1.
And F's? 0. If you've drawn them in such a way, as I sort of did here, you're actually able to shade so that it's more obvious what's going on. So here's my blue graph. Everything in blue is going to be exam 2. You can shade with a marker, you can shade with your pencil. If you have just a pencil and you don't want to do colors, like you don't have any with you, you can do cross hatchings. So you'd shade, like diagonally downwards, from the top left to the bottom right in one of the columns, and then the other sets of bars you shade, horizontally or vertically or something like that. And then you can do the same thing here with the greens. What I want to do, and the reason I'm making mention of doing this, is because you've got to be able to write a key that tells what in the world these different bars represent. Because now I've got 2 sets of bars here, right? So I want to represent that the green, right, are exam 1 scores. And that my blue are exam 2 scores. It's part of the key to being able to read this graph. I also need to write in frequency over here. And then there's one other thing I need to do. What is it? I need a title. And we can use similar titles to what we did back in that back-to-back stem and leaf plot. What do we use for our title over there? Exam scores on what, Beth? Okay, so normally you'd write the, are you okay, Beth? Yeah. Okay. Normally we'd write that down, closer to the graph, but I'm kind of out of space here. But the title for this graph is these are exam scores on first and second exam. Make sense? Okay. Next one. And I should have brought them with me. I'll have a solution for us shortly. But all right, so this is a pie chart or a circle graph. Have you guys seen these before? Pie charts and circle graphs are used when you know the whole amount of something because you're doing a comparison of something to the whole. So what they do is they give you a really good picture of, the whole pie of something, so to speak, and then you can splice it apart in such a way that you can look at it and say, oh my goodness, that was over half. Or, oh my goodness, it's about a third. And you can see it as a visual, whereas if you look at it in bars, you may not be able to see that very well. You may be able to see that, hey, yeah, there are a bunch more A's, but you can't see that, oh my goodness, 75% of the people got an A, which is a little bit different picture of what's going on. So it consists of circular regions partitioned into disjoint segments, and it shows how the parts are related to a whole. We're going to use the grouped frequency table that we did a couple examples back to construct a circle graph for the letter grade for exam 2. Okay? So we need some information before we can just start constructing a circle graph. We actually need to talk about the tallies or the totals of each of these values. So let's talk about the letter grade A. There was 11 of those, right? How many B's were there? 4. C's? 2. And D's? 1. For a total of how many grades? How many grades is that? 18? Okay, so what we're going to do is we're going to figure out how much of the whole that is. That is, what percentage are we talking about here? We've worked with percentages in this class, right? It's been a couple of tests ago, but you have, and you just finished redos on them. You can figure out this 11 to this 18 by taking the 11 and dividing by 18, and then multiplying it by 100. 11 over 18 turns it into a decimal, and multiplying by 100 turns it into a percentage. And we can do this with each of our values. So we can also do 4 over 18 times 100. 2 over 18 times 100. And 1 over 18 times 100. All right, so somebody tell me, what do you get when you take 11 over 18 and multiply by 100? What do you get? Okay, and we'll go with 1 decimal, well, okay, yeah, that's fine. 1 decimal, 60 what? 61.1%. Okay. Now, before we move away from that and go to the next one, I'm also going to need to know how much of a circle that is. So how many degrees are there in a circle? 360. Excellent. Some of you have had math 3. All right, so 360 degrees in a circle, and there's 61.1% of that is this letter grade A. So instead of doing the 61.1, I'd like for you to keep the 11 over 18 in your calculator. Because 11 over 18 was the value as a numerical value between 0 and 1, right? It was like a probability kind of thing. Yes, that was the last test we did. Take that 11 over 18 and multiply it by 360 instead. So if you did 11 over 18 times 360, you'd find out how many degrees of a circle this would represent. And what is that? 220 degrees. Okay, so it's going to represent 61.1% of the circle, and it's 220 degrees. All right, next one. What is 4 over 18 times 100? 22.2%. And what is that same 4 over 18 times 360? 80 degrees. Now the reality is, if you've already found that one, you should be able to find the next one without your calculator. Because how is 4 over 18 related to 2 over 18? It's half. Well, it's double. Yes, to do it, we do half. So the 22.2% would be 11.1%, and the 80 degrees would be 40 degrees. Yep, good. All right, and then the last one should just be half of that, right? So if you're not sure, you can do the 100 or the 1 over 18 times 100. What does that give you? 5.5%. And of course, this is not going to add up to exactly 100, but it should be adding up to approximately 100, right? Now, what is the 1 over 18 times 360? That is, what is half of 40? 20 degrees. All right, so these are the different degrees that we need in our circle to represent the different categories of data. All right, so we're going to use, I'll use this screen. Even better, I'll go like this. You're going to create a circle next, okay? So if you have a cup or a water bottle, you could use that to trace around it to get a good circle. If you don't, just freehand it right now to the best of your ability. When I ask these questions on a test, I put a circle on there if I need you to have one, so you don't need to worry about being able to draw a perfect circle. I have the advantage of having technology. So my circle looks really good right now. All right, so I have this circle, and I need to take the circle, and I need to place first a dot in the center of the circle, okay? And the next thing you're going to do is you're going to draw a radius of the circle out to wherever you want in the circle. I don't care. Does anyone happen to have a protractor with them today? Didn't think so. All right, and if I had my smartboard on, I would be able to do it on the smartboard, but of course I don't. So I will. I'll go get the protractor shortly, and we'll finish the problem from there. But from the protractor, what we're going to actually do is we're going to line up the center of a protractor at the center of the circle. All right, and we're going to look around the edge of the circle, or of the protractor, and it will have degrees around the edge of the protractor. A couple of things that students tend to mess up on in the particular circle. This is letter grades. So it does not make sense to go A, D, C, F, B. Okay? They need to be in order, right? So, you know, if you were looking at outcomes that were, say, housing prices, you wouldn't look at the housing prices that were in the 100s and then look, you know, compare it to the next slice of the pie is in the 400,000s and the next in the 200,000s and the next in the 300,000. You put them in order. So you need to have an ordering of what's going on, okay? You also need to put certain pieces of information on your graph. So I'm going to eyeball this for now, and I'll bring the protractors in to show you the exact procedure here. But let's say, using my eyeball right here, that that's the 220 degrees for A. Okay, so let's say that right there is 220 degrees. So you need to mark in here that this is 220 degrees somewhere, that it's the letter grade of A, and you need to put the percentage of the circle that it is. So in this case, this was 61.1%. Okay? That's the kind of image that you'd have when you had finished with that. The next letter grade in order should be the letter grade B. I don't care which side of A it's on, but it does need to be touching A. So the letter grade of B was 80 degrees. So 80 degrees is slightly less than a 90-degree angle. A 90-degree angle would be about right there. Right? Do you see that 90 degrees in the top left-hand sort of corner? So I'm going to make mine slightly less than that, so this would be 80 degrees. Again, we'll do it more precise when we have the tools to do so. But this is 80 degrees. This is the letter grade B. and it represents 22.2% of the data. The next letter grade in order would be the letter grade of C, right? So we'll put the letter grade C next. It's supposed to be 40 degrees, and the last one's 20 degrees. So this needs to be split in about 2/3, 1/3. That's not exact, but it's pretty close. So this would be 40 degrees, and this would be the 20 degrees. This is my C. This is my D. This is 11.1%. And this right here, where I don't have space to write it, rather, is 5.5%. And if you do draw your circle too small, or if you just write a little bit larger and you don't have the space, it's okay to do that, to mark the, sort of an arrow on the outside showing the piece for the inside. But you do need to have the degree measure, the percentage, and the label of this. And we need one more piece of information. A title. What would this be? Same as before, right? Grades on a second exam. Any questions on that?
Are we going to need to have a protractor for that?
I will have the protractors here just in a minute, and you can actually do the group work. I think there's a group work problem with it. In terms of for your homework, if you don't want to have to go get one, and that's fine if you don't want to go get a protractor, you're welcome to come to my office to use them. I think I have 3 or 4 of them in there, and I will have them here for the test too. So if I ask you a test question, I will have the protractors in the classroom for the test. Okay? Any other questions? Okay.